Hello, hello, hello.
Hello, good afternoon, sir.
Yes, good afternoon. How are you, Aditya?
Sir, I'm fine.
Okay, okay. Okay. So now I start chapter trigonometry. Okay. Today, in this session, I can explain trigonometry. Okay.
All right, sir.
Okay. So first of all, I explain in this trigonometry. Okay, trigonometry is used for which kind of triangle and what is the application. Okay, application means how we can use, and application means how trigonometry is useful in our daily life. Okay, that I can
Okay, sir.
explain. Okay, so first this chapter is okay. You are from CBSE board or
Yes,
ICSE?
CBSE 10th class.
Okay, okay, good. So now in CBSE, this trigonometry, that is chapter number 8. Okay,
Okay, sir.
you see the screen now.
Yes, sir, I can see.
Okay, so in this trigonometry, okay, so first of all I explain what is the meaning of this trigonometry. Okay, so
Okay,
tree means what? Tree means 3. Okay, here in this maths, meaning of tree means 3. Gone means, okay, here gone, trigonometry, so GON. What is the meaning of this one? So 3, this one is sides. Okay, and
okay, sir.
metry means this metry, that is from measure. Okay, this word is comes from measure. Okay, so the meaning of this one is 3 side measure. Okay, and now
Okay,
this
sir.
trigonometry is only applicable for right angle triangle. Okay, this one trigonometry metry is used in right angle triangle. Okay, trigonometry is
Okay, sir.
used in any kind of right angle triangle. Okay, we have a different kind of right angle triangle. One is a simple right angle triangle, and another one is a isosceles right angle triangle. Okay, we have a two
Okay,
type of right angle triangle. What is the difference between these two triangle? I can explain. Suppose here I can draw the one triangle. Just 1 second. Okay, so here you see that I can draw the triangle. Okay, so this one is a right angle triangle, simple right angle triangle we have. And here you can see that this angle is a right angle. Suppose I give the name, that is A, B and C. Okay, and
okay, sir.
here another thing is second right angle triangle, that is a isosceles right angle triangle. You know what is isosceles triangle? Simple.
Yes, sir. In which two sides are having the same
Yes.
dimension.
In a triangle, we have two sides are equal. That is called isosceles triangle. But another thing is right angle isosceles triangle. That means two sides are equal, and also angle,
Two
that
angles
is
are equal.
one angle is right angle. Yes, other two angles are equal according to their side. But right angle
Okay,
isosceles triangle, that means here I can say this angle. Suppose I consider triangle PQR. Okay, and here Q is a 90-degree right angle. That means in this one is a isosceles right angle triangle. Second one, this figure B. Okay, and this figure is a simple right angle triangle. So this trigonometry is applied for these two kinds of triangle. Okay, And now we have in trigonometry we have a six trigonometric ratio. Okay, I can explain all the ratios. Okay, one by one, formula and the ratios. Okay, so here I can draw another one right angle triangle, and every right angle triangle we have a one hypotenuse. Okay, and that is also opposite of a right angle. Hypotenuse is always opposite of right angle. So here this one is my right angle, and here I can consider triangle ABC. Okay, so in this one, in triangle ABC we have angle B is a 90 degree. So here this one is my AC is a hypotenuse, because AC side AC is a opposite of angle B. Okay,
90
so
degrees.
for hypotenuse I can use H. Okay, we in short form I can write hypo. That means we use symbol H. Now this AB is a perpendicular 90 degree, and BC is a, we can consider as a
Base.
side base. Yes, this one we can simply consider as a base. So for base we can use B, and this one is a perpendicular, so we can use symbol P. Okay, we can also use another symbol, that is this one is the adjacent of angle A, and this one is a adjacent of angle C. That formula we can also use. Okay, now we have a six trigonometric ratio. Suppose if we consider sine theta. Okay, we have sine theta, cos theta. Theta means angle. Tan theta, cot theta, then we have cosec theta and sec theta. Okay, these are the six trigonometric ratio we have. Now we can derive the formula for this six trigonometric ratio. And when we have this kind of triangle, okay, in trigonometry always all the triangles are right angle. So in right angle triangle, we also use a Pythagoras theorem to find the remaining side. If two sides are given, then we can find the third side. And triangle is right angle, so we can use Pythagoras theorem. Okay, and now we can also use this trigonometric ratio. So what is the formula of this one? So sine theta. Here we can suppose take this angle A as a theta, or we can also take the angle C as a theta. Okay, B we cannot take a theta because B is already given 90 degree. Understand?
Yes, sir.
So if we take suppose this angle is a theta, so formula for sine theta is what? That is opposite upon hypotenuse.
Hypotenuse.
So here, if we consider this one is my angle theta, so formula for sine is opposite upon hypotenuse. So opposite of angle A, that is this BC, and BC we can suppose here consider that is base B, and hypotenuse we can consider H.
H.
Understand?
Yes, sir.
Similarly, if we find cos theta, so cos that is adjacent upon hypotenuse. So adjacent of angle A, because here we can suppose angle A is theta. So that is this perpendicular. This AB is a adjacent side of this angle. Understand? Because this one is a
Yes, sir.
hypotenuse. So this one is a adjacent of theta. So here that is P upon hypotenuse H. Understand?
Right.
Yes. If you have any doubt, so you can ask me. Okay, so I can explain. Next one is tan theta. Tan theta, we have one formula, that is sine theta upon cos theta. Okay. So here, if we take using this one, sine theta means B upon H divided by cos, that is P upon H. So here B upon H, and we can this division we can reciprocal of reciprocal, that is converted into multiplication. So that is H upon P. So here H cancel. So we get B divided by P. So this one is formula of tan theta, that is based upon perpendicular. And another we can also say opposite upon adjacent. Okay. In textbook they can use opposite upon adjacent. Understand?
Yes, sir.
Okay. Now sine theta we have B upon H. So we have cosec theta, that is equal to 1 upon sine theta. So that means cosec that is 1 upon sine, so we can only take a reciprocal of this sine theta, that is b upon h. So reciprocal of b upon h, that is h upon b. So this formula is for cosec theta. Similarly, we have sec theta, that is also 1 upon cos theta. That means reciprocal of cos is what? Cos theta here, p upon h. So reciprocal of cos is h upon p. So this one is a formula of sec theta. Understand?
theta.
And also
Right, sir.
same thing we have cot theta, that is reciprocal of tan theta. So reciprocal of tan, that is p upon b, perpendicular upon base. Understand?
Yes, sir.
Otherwise you can also say adjacent upon opposite. That is also, both are same. You have to remember any one. Okay. So you can understand all these six trigonometric ratio. These
Yes, sir.
all are called trigonometric ratio. Okay, these are the trigonometric ratios. Now, what is the use of this trigonometric ratio? Or just okay, I can take one example, so you can easily understand. I can take one by one example how to use. What is the application of this trigonometric ratio? Okay, so just 1 second. Now you see this example number one.
Yes, sir.
Okay, so here we have tan A is given. Okay, and value of tan A is given 4 upon 3, and we can find the other trigonometric ratio of angle A. So in this question, one important thing is tan A is given. Okay, so here we have to suppose we consider triangle ABC. Okay, and here angle tan A is given 4 by 3. So A cannot be taken 90 degree. We have either B or C. Anyone we can take as a right angle. Okay, so in triangle ABC, suppose we have to consider, in triangle ABC, suppose we can consider angle B is a 90 degree, means right angle. Okay, so here I can draw the
Okay,
rough
sir.
figure, because tan A is given 4 by 3. So A cannot be take as a right angle. Understand? Either we can use B or we can use C as a right angle. Understand?
Okay, sir. Yes, sir.
So now uh, this one, in this figure we can consider, according to this question we have, suppose here B is my right angle. A I can take here or here, any place. Okay, suppose I can take A here. Now here tan A is given, in this question tan A is given 4 by 3. So now we can use our trigonometric ratio formula to find other 5 trigonometric ratio, because we have total 6 trigonometric ratio. Okay, so already one trigonometric ratio is given, and using this one we can find the other trigonometric ratio. So according to this formula, tan theta, here in our formula we have considered theta. In our question we have A is an angle. Okay, but formula is same. So that is based upon perpendicular, tan means. Okay, and here
Okay, sir.
we can compare with this one based upon perpendicular. Now you can compare 4, that is base, and perpendicular, that is 3. So that means according to this figure, this one is our base and this one is our perpendicular. Understand this thing? How can I put here 4 and 3?
Yes, sir.
Okay, now we can we have to find the 5 trigonometric ratio, but one thing we have remaining, that is hypotenuse. Okay, so how can we find hypotenuse? So here right angle triangle is given.
Pythagoras theorem.
Yes, so by Pythagoras theorem, okay, by Pythagoras short form I can write theorem in THM. Okay, here AC is a hypotenuse, so we can write AC square. Pythagoras theorem is hypotenuse square equal to sum of square of two sides. So AC square is equal to AB square plus BC square, and now we can put the value and we can find the hypotenuse, that is AC. So here we can 3 square plus 4 square. So can you tell me what is the value of AC here? Hello.
Sir, it is 5.
Yes, because 9 plus 16, so 25. So yes, correct answer. So AC, that we get 5. So here we get hypotenuse, that is 5. Now we use our trigonometric ratios formula. Okay, tan theta is given, so we can directly find here tan A is given, so cot A, that is reciprocal of tan A, so that is cot A, that is 3 by 4. Understand?
4. Yeah, sir.
Now if we find sin A, so formula of sine is what? Here I can write this one is hypotenuse, this one is base, and this one is perpendicular. Okay. So for
Sir, it will
sine,
be 4 upon 5.
yes, 4 upon 5, correct. Then if we find cos A, that is perpendicular upon hypotenuse, that is 3 by
3 upon 5.
5. Now sine and cos we already find here. So cosec is reciprocal of sine, cosec A, that is 5 by 4, and
4.
sec, that is reciprocal of cos, that is 5 by 3. Understand?
3. Yes, sir.
So this one is application of this trigonometric ratio. We can, using this ratio, we can find other trigonometric ratios. And also one important thing is, in our house, if we consider two wall, okay, so two wall are also at a right angle maximum. If uh, in some house we can create some different design, then it is different angle, but maximum two walls like is this angle, 90-degree angle. Understand?
Yes, sir. Yes, sir.
Okay, now I take some different example, so you can easily understand. Okay, now I take another example. Okay, in this example you can see that a right angle in triangle ABC. Okay, B is a right angle given, B is a right angle. Okay, so here we can draw the rough figure. In this one we have B is a right angle, and here we can consider A, and here we can take C. Okay, and in this one also they give tan A is equal to 1 given. Okay, so 1 given, so we can also write this 1 is equal to 1 upon 1. Understand?
Yeah, sir.
And now we apply the formula of trigonometric ratio of tan A. So that is formula is what? Based upon perpendicular. So that means this value is 1 and also this value is 1. So here again we can apply by using Pythagoras theorem, because we can find hypotenuse. And now we first we can find by using Pythagoras theorem, we can find hypotenuse. Understand?
Yes, sir.
By Pythagoras theorem we can find, so hypotenuse is AC, so AC square is equal to AB square plus BC square, and here we get that is 1 square plus 1 square, and therefore we get AC square is equal to 2, and therefore we get AC is equal to square root of 2, that is root 2, because here 2 is not a perfect square. Understand?
Yes, sir.
And now we, in this question we get hypotenuse is root 2, so this one is hypotenuse base and this one is perpendicular. Now in this question we have to verify the value 2 sine A into cos A is equal to 1. So here we can take a left hand side, that is 2 sine A into cos A, and then we have to check our answer is 1 or not. Okay, so according to this figure, and according to this figure we can find the value of sine A. So sine A is what? Here we can use this angle A because they give sine A. Okay. So here I can write down the value of sine A, that is based upon hypotenuse. So that is 1 upon root 2. And
Root 2.
similarly we can find cos A, that is perpendicular upon hypotenuse. So perpendicular is, that is also 1 according to figure, and hypotenuse is root 2. So now we can put both the values. So sine A, that is also 1 upon root 2, and cos A, that is also 1 upon root 2. And now here we get numerator is 2 and denominator root 2 multiplied by root 2. Okay, I explain by. root x multiply by root x. So here we can also write this one is root x square. Okay, root x means what? Square root means we can write 1 by 2, and here square is as it is. So that is equal to x raised to 1 by 2 into 2. So 2 to cancel. That means root 2 multiply by root 2, that is x. Okay, why we can write this one? Because here we can use one another important rule, power of exponent rule. Which rule I can take here? A raised to m raised to n, power of power, that means we have to multiply that power. This rule I can use in this step. Okay, that means root x into root x, that means simply x. Similarly here root 2 into root 2, that is equal to 2. Understand?
2.
And
Yes, sir.
therefore these two are cancelled and we get 1. And here we have to verify. In verification, right hand side is also given 1, that means this one is true. We get here right hand side. Understand? So this one is true for this question. That means 2 sine a into cos a is equal to 1 always. Here only important thing is this angle are same. Suppose here we can take 2 sine c cos c. For this angle, if we check, that is also true. Okay. Only thing,
Yes, sir.
both angle are similar. So this result is true for this one. Next question. Okay. Next example I can take. Okay. In this question, in triangle OPQ, here I write down the figure. Okay. So you can understand. In triangle OPQ, angle right angle at a P. Okay. For example, this one is our triangle OPQ, and here right angle is given at a P. So here I can take a P, O, and here Q. Okay. In this question, they give two different value. One is given OP is equal to 7, and another is OQ minus PQ is 1. Okay. So OP is equal to 7 given, and we can also use OQ minus PQ is equal to 1. So using this second one, we can write also OQ is equal to 1 plus PQ. Understand this second step?
Yes, sir.
And now we can use Pythagoras theorem to find these two value, because here we can find sine Q and cos Q use for this angle Q. That means if we find sine q and cos q, so we must need these two sides, value of this hypotenuse and perpendicular. So now we can use Pythagoras theorem in this triangle. So OQ is a hypotenuse, so OQ square is equal to OP square plus PQ square, and now we can put this value. So OQ means 1 plus PQ square whole square. OP, that is given 7, so here I can write 7 square plus PQ as it is, PQ square. Understand this step?
Yes, sir.
Now here we can use a plus b whole square formula, algebraic identity, that is a square plus 2ab plus b square. That means 1 square is 1 plus 2 into 1 into pq, that is 2pq plus pq square. Understand?
Yes, sir.
And this equal to 7 square, that is 49 plus pq square. Now here you can see that pq square is cancelled because these two are same and different sides of equal to. And now this one is going to other side, so we get simplification, that is 2pq is equal to 49 minus 1, that is equal to 48. And therefore we get here pq is equal to 48 by 2, that is equal to 24. Understand?
Yes, sir. I got it.
And now using here, this one is my first result. Okay, so using this first result, we can also find OQ, that is 1 plus PQ, and therefore that is 1 plus 24, so we get that is equal to 25. So here we have OP is equal to 7, OQ we get that is 25, and PQ that is equal to 24. So now we get all this value, this PQ is 24 and this one is 25. So this one is hypotenuse, this one is our base, and this one is perpendicular. So here we can easily find the value of sine q and cos q. Okay, so here if we find the value of sine q, that is based upon hypotenuse.
Sir, we'll get
Yes.
7 by
Yes,
25.
7 by 25. If angle O we consider, for angle O, this one is base and this one is perpendicular. And if here we can use angle Q, so my base and perpendicular are changed. Okay, because we can use here for angle Q. So that means this one is a perpendicular for angle Q and this one is a base. Understand?
Yes, sir.
And therefore that is opposite. Otherwise, you can simply opposite upon hypotenuse. That is 7 by 25. And similarly, we can find also cos q, that is perpendicular upon hypotenuse or that is adjacent upon hypotenuse, that is 24 divided by 25.
Right.
Understand?
Yes, sir.
Okay. Any doubt in these questions?
No, sir.
Okay, good. If you have any doubt, so you can ask me. Okay, so I can explain. Next to one. Okay, now I take another question. Okay, in this one, triangle ABC is given and we have angle B is a right angle. Okay, in this question they give B is a right angle. Just second. Yes, B is a right angle and AB and BC are given. Okay, so here we can draw the triangle and angle B, that is a right angle. Okay, so here we get this angle B is a right angle, and here we can take A and here we can take C. So AB is given 24, BC is given 7, and then we can find the value of sine A, sine C, and cos C. Okay, so here we can apply Pythagoras theorem to find this hypotenuse AC. So here AC square is equal to AB square plus BC square, and therefore AB, that is 24 square, BC, that is 7 square. So 24 square, that is 576 plus 49, and therefore here we get AC square is equal to 625, and therefore square root of
We'll get
this
it
one is,
25.
yes, 25, correct. And therefore here we get our hypotenuse is 25. And now we can find the value of sine A, cos A, sine C, and cos C. So here in first we can find sine A. So we can use here this angle sine A. So base upon hypotenuse, for this angle base, that is 7, hypotenuse is 25. If we take cos A, so cos, that is perpendicular upon hypotenuse or otherwise adjacent upon hypotenuse, that is 24 upon 25. Second we can find, that is sine C and cos C. So sine C, that means we can use this angle sine C angle. Okay, here we can use theta, this angle we can use. So for this angle we can find sine C. So opposite, that is 24, and hypotenuse is same, so that is 24 upon 25, and for cos C, that is 7 upon 25. Understand?
Yes, sir.
Okay, in this one also, one thing that is important, here you can see that sine A and cos C have a same value, because here trigonometric ratio is changed and also angle is changed, sine and here trigonometric ratio cos, as well as here we have angle A and here angle C, and then both have a same value. Understand? So this one is also important, why these two
Yes,
have a
sir.
same value. Similarly, cos A is equal to sine C, because also trigonometric ratio is changed and also angle is changed. Next question. Okay, in next question, figure is given and we have to find the value of tan p minus cot r. Just one second. Okay, in this question this figure is already given and we have to find the value. Okay, find the value of tan p minus cot r. Okay, so if we find first of all we can find this third side. So we can use Pythagoras theorem, that is PR square is equal to PQ square plus QR square. Okay, and therefore we get PR is given, that is 13 square is equal to PQ, that is 12 square plus QR square. And here 13 square, that is 169 square, that is 144 plus QR square, and therefore we get QR square, that is equal to 169 minus 144, that is 25, and therefore we get QR, that is equal to 5. Understand?
Yes, sir.
So here we get this side is 5 centimeter, and now we can use tan p minus cot r. We can find the value of tan p minus cot r. So we can put the value of tan p minus cot r. So value of tan p. Okay, tan p, that is what? Here we can use this angle p. So that is a base upon perpendicular. So for this tan p, base is 5 and perpendicular is 12. If we use cot r, okay, here angle is changed and also trigonometric ratio is changed. So cot r is what? That is perpendicular base upon perpendicular. Okay, that is 12 upon uh,
Uh,
yes,
Sir, it will
5 by
be 12
similar
upon 12.
5 by 12, because here this one is also, if we use tan r, then that is 12 by 5, but here cot r is given, so reciprocal of tan r, or otherwise we can directly find the value of cot r, and here we get 5 by 12 minus 5 by 12, so we get answer is 0. So here we get tan p minus cot r, that is equal to 0. Understand?
Yes, sir.
Okay, so this one is a use of this trigonometric ratio. Okay, I can also take one more example. uh, yes, I can take one example that is also important. Okay, in this example we have cot theta is given 7 upon 8. Okay, so here we can also using triangle we can also find the other value, otherwise we can directly use formula to find the value, but using triangle that is easy. I can explain. Just one second. Okay, here you can see that this angle, this one is my triangle, and here this one is a right angle. And in this question, they already given cot theta is equal to 7 upon 8 is given. Okay, so here we can suppose consider either this angle or this. Any one we can take as a theta. So suppose I can consider this one is a theta, and here we can consider name any name abcpqr or xyz etc. Okay, so here if I consider this angle is a theta, and now cot theta is 7 upon 8 is given. So cot theta is what? Cot theta according to formula of uh, trigonometric ratio. Okay, here cot theta, that is perpendicular upon base, or we can say adjacent upon opposite. Either use this one. So here if we consider this one is a my angle theta, so this one is a perpendicular and this one is a base, so this value we can consider as a 7 and this one is a 8. Understand?
Yes, sir.
And now we can apply Pythagoras theorem to find out the value. So here that is perpendicular upon base, and now we
Sir,
can
I think, sir, I think so. It will be opposite.
yes.
BC should be 8 and AB should be 7.
uh, yes, just one sec. Yes, here we have formula that, for cot theta, that is adjacent, yes, adjacent upon opposite. So here adjacent, that is this one, yes, 7 upon 8. This one is 7 and 8. Yes, this one is a perpendicular and this one is yes. Okay, so now we can use, yes, correct. So a Pythagoras, so we can use AC square is equal to AB square plus BC square, and here AB, that is 7 square, and this one is 8 square, so 7 square is 49 and this one is 64, and therefore we get AC square. So AC square is equal to, if we add, so that is equal to 113. Okay, and therefore if we find AC, so this one is not a perfect square, so that is the value is square root of 113. Understand? So this one is a
Yes,
hypotenuse.
sir.
And now we can evaluate this value, 1 plus sine theta, 1 minus sine theta. Now in this one we can also use one identity. Okay, the identity, that is this one. If we have a plus b, a minus b, you know what is the formula of this algebraic identity? If we have this
Sir,
one,
A
that is,
square minus B square.
yes, so same thing is here, 1 plus sine theta, 1 minus sine theta. So here a 1 means a and b means sine theta, that is a square minus b square. So first I write this one, 1 plus sine theta, 1 minus sine theta upon 1 plus cos upon, here 1 plus cos theta into 1 minus cos theta. So using that formula we can write 1 square is 1 minus sine square theta. Similarly here 1 minus cos square theta. Understand?
Yes, sir.
And also 1 minus sine square, that is cos square, and 1 minus cos square, that is sine square. That is also another trigonometric identity. Otherwise here we can find sine theta and cos theta. Then we can also put this value sine theta, that means 8 upon square root of 113, and cos theta, that is 7 upon square root of 113. Understand?
Yes, sir.
So we can also use this value to find out this one. So here 1 minus sine square. So sine square, that is 8 upon under root 113 whole square upon 1 minus cos, that is 7 upon square root of 113 whole square. So now we can simplify. So here 1 as it is, 8 square is 64, and here square and square root is cancelled. So we get 113, and here 1 minus 49 upon 113. Understand this step?
Yes, sir.
Now here we can take 113 is a LCM. So 113 minus 64 in numerator, that is 49 upon 113. Similarly here 113 minus 49, that is 64 upon 113. And if we simplify this one, so that is we get 49 upon 64. Understand?
Yes, sir.
Okay. Second, we have to find, that is cot theta square. So here cot theta is already given, that is 7 upon 8. And here we can find cot square theta, that is 7 upon 8 whole square. That is also 49 upon 64.
Four.
Understand?
Yes, sir.
Okay. Next one. Okay. Next, I explain trigonometric ratio of some specific angle. Okay. Next topic is trigonometric ratio of some specific angle. Of some specific angle. So here, which angle we can consider as a specific angle? So here we get we can consider trigonometric ratio in specific angle. We can use 0 degree, 30 degree, 45, 60, and 90. Okay, these angles are a specific angle for trigonometric ratios. Okay, and here for all these six trigonometric ratio we can find the value of all these: sine 0, sine 30, sine 45. Similarly for cos, tan, cot, cosec, and sec. Okay, all we have to find. So I can explain how we get that value. Just second, I can draw one table. So here I first column I can take my trigonometric ratio, that is sine, cos, and here we use 0 degree, then 30, 45 degree, 60 and 90. Okay, so here I can write my trigonometric ratio sine theta. Okay, then we have a cos theta, tan theta. Okay, first I explain this one. So here we have trigonometric ratio. In short form I can write t ratio. Okay, t ratio, that means trigonometric ratio. Here for 0 degree, 30 degree, 45, 60 and 90. So how can you remember the value of this trigonometric ratio for sine theta? Okay, so here we can take a square root of each and every 0 by 4. Here we can take 1 upon 4, square root of 2 by 4, square root of 3 by 4 and square root of 4 by 4. Okay, this one is useful to find the value of sine theta, and according to sine theta we can find all other values. Okay, so first of all, 0 upon 4, square root of 0 upon 4 is what? 0, because 0 divided by 4 is 0 and square root of 0 is 0. Can you tell
0.
me what is the value of square root of 1 upon 4?
Sir, it will be 1 by 2.
Yes, it is 1 upon 2, correct. Similarly, 2 by 4 is given, so 2 by 4, that is 1 by 2, and square root of 1 by 2, that is 1 upon root 2. Similarly here, square root of 3, that means root 3, and square root of 4, that is 2. So we get here root 3 by 2. And 4 upon 4, that is 1, so square root of 4, this one is 1. So here you can see that sine 0, that is 0, sine 30 1 upon 2, sine 45 1 upon root 2, sine 60 root 3 by 2, and sine 91. Okay, now how can you remember the value of cos theta? You can write from this one, start from this one. Here you can write 1 reverse. Okay, then root 3 by 2, this one is as it is 1 upon root 2, here 1 upon 2, and this one is 0. Understand how can we find the value of
Yes,
cos?
sir.
Yes, now tan theta, we have formula, that is sine theta upon cos theta. So we can use that formula here to find out the value of tan theta, that is sine theta upon cos theta. So here, how can we find the value of tan 0, that is sine 0 upon cos 0? So 0 upon 1, that is 0. Understand?
Yes, sir.
Similarly, 1 by 2 upon root 3 by 2. So 2 to cancel, that is 1 upon,
1 by root 3.
yes. Here both value are 1 upon root 2, 1 upon root 2. So that is 1. Here we get a root 3, and here 1 upon 0.
Not defined.
Yes, that is, we can say infinitive or we can say not defined. Okay, so here we can write not defined. Now we can find the value of cot theta. Okay, so cot theta, how can, so cot, that is also same reciprocal of this 10. Okay, reverse, we can write the value of cot, that is all exactly reverse. So here we can write this one is not defined. Here we have a root 3. Just second, I can scroll up so you can see. Then cot 45, that is 1, cot 60, that is 1 upon root 3, and cot 90, that is 0. Understand?
Yes, sir.
Okay. Similarly, here we can find the value of sec theta and cosec theta. Just one second. So here we can easily also find the value of sec theta and cosec theta using sine and cos theta, because we know that sine theta, that is also reciprocal of sine theta, that is cosec theta, and reciprocal of cos theta, that is sec theta. So here if we find value of sec theta and cosec theta, okay, first we can take suppose sec theta. So you know that sec theta, that is equal to 1 upon cos theta, and here these values are cos theta, so 1 upon cos 0 is 1, so 1 upon 1 is 1. 1 upon root 3 by 2, that is reciprocal of this value, that is 2 upon,
2 by root 3.
yes. Then we have a root 2, 2, and here 1 upon 0, that is not defined, because dividing by 0, that is not defined. Any number divided by 0 is not defined. Understand? And now
Yes,
we
sir.
can find the value of cosec theta. We have a two method. Either we can write the reverse value of this cosec theta, otherwise we can take 1 upon sine theta. Okay, so if I take 1 upon sine theta, so that is 1 upon 0, that is not defined. Otherwise we can write this value here, then 1 upon root 2, 1 upon 2, that means reciprocal of this one is 2. Here we get a root 2, 2 upon root 3, and here 1. Understand?
Yes, sir.
So these are the all trigonometric ratio in specific angle. Okay, for 0 degree, 30, 45, 60, and 90. And we can use this all the value according to this table. So now you understand how can we make this table. Okay, only using this trick, 0 square root of this value, that is the value of sine theta according to 0, 30, 45, 60, and 90. Okay, now I take some examples using this trigonometric ratio of specific angle. Okay, just a second. Okay, I can take a different kinds of example. Okay, suppose we have to find the value of this one, sine 60 cos 30, okay, plus sine 30 cos 60. So according to table we have to put the value. Sine 60, that is root 3 by 2. Here multiplication cos 30, that is 1 upon 2. Understand? Here I show you the
Yes, sir.
table so you can understand. Okay, sine 60, so we get put this value root 3 by 2. Cos 30, that is sorry, here we have cos 30 or 60. Yes, cos 30 is given, sorry. Cos 30, that is also root 3 by 2. Okay, plus sine 30 is given. Sine 30 is 1 by 2, and cos 60 is also 1 by 2. You can see on the table, you can see here cos 60 is 1 by 2 and sine 30 is also 1 by 2. Now we can simplify. This one is product, so root 3 into root 3, that is 3, and here 2 2s are 4, and here 1 upon 4. So if we take here 4 LCM, that means 3 plus 1 upon 4, that is 4 by 4. So we get answer is 1. Understand?
Yes, sir.
Okay. So here using this trigonometric ratio of specific angle, we can find the different value of this trigonometric ratio. But only here this table is useful for angle is given which is 30, 60, 45, and 90, and 0 degree. Okay. Now this one is second question. In this one we can find evaluate the value of tan square 45. So now tan 45 is 1, and here square is given, so we can put square. Okay, cos 30, that is root 3 by 2, and here square cos square, so we can put square. Sine 60, that is also root 3 by 2 whole square. So here we get 2 into 1 square is 1, plus root 3 by 2 square, so that is 3 by 4, and here also root 3 by 2 square, that is 3 by 4, and this one is plus and minus, so cancel. So here we get answer is 2. Understand?
Yes, sir.
Okay. Similarly, we can also find the different value using this one. Okay, I can take one another combined example of all the ratios. Suppose we can find this value, sine 30 plus tan 45 minus cosec 60, and this one. So here we can put sine 30, that is 1 by 2, plus tan 45 1. Okay, cosec 60. Cosec 60 is what? 2 upon root 3. According to table, you can see that we have to find cosec 60. Okay, this value we can take. Otherwise, you can, if you remember only sine, cos, and tan, then you can also write, because reciprocal of sine, that is cosec. Okay, here sec 30, that is also 2 upon root 3, plus cos 60, that is 1 by 2, and cot 45, that is 1. Okay, and here we can take LCM. So 2 root 3 is our LCM in numerator. So here root 3 is multiply, plus here we get 2 root 3 minus 4. Understand this step?
Yes, sir.
Divide by, in denominator also we have 2 root 3 is LCM. So here we get 4 plus root 3 plus 2 root 3. And now we can simplify this one. So here we get root 3 plus 2 root 3, that is 3 root 3 minus 4 upon 2 root 3. And here I can take reciprocal of this value. So 2 root 3 is in numerator, and here 2 root 3 plus root 3, that is 3 root 3 plus 4. Understand?
Yes, sir.
And here 2 root 3 cancel. So here we get 3 root 3 minus 4 upon 3 root 3 plus 4. Now in trigonometry we can also simplify this one, because here we have a, in this one we have a denominator in square root. So we can remove the square root by multiply this opposite sign. 3 root 3 plus 4 is given, so that is known as a conjugate. Okay, so here plus is there, so we can multiply by negative sign, only this sign is changed. And here in numerator we get 3 root 3 minus 4 whole square, because this term is 2 times. And denominator, that is a plus b, a minus b, because in denominator you can see that this one is a, suppose, and this one we can b. So same here, a plus b, a minus b. So that is a square minus b square. So 3 root 3 square minus 4 square. Understand?
Yes, sir.
And here we can simplify, that is 3 root 3 whole square, that is 3 square 9, 3s are 27, minus 4 3s are 12, 2s are 24 root 3 plus 16, divide by 3 root 3 whole square, that is 27 minus 4 square is 16. Understand?
Yes, sir.
So here if we simplify this one, so 27 plus 16, that is equal to 43, minus 24 root 3 as it is, and divide by, we have 27 minus 16, that is equal to 11. Understand? So this one is the final answer. Any doubt in this question?
No, sir.
Okay. Then I go for the next question. Okay. In this question, tan a plus b is given root 3, and tan a minus b is given 1 upon root 3. And in this one, they can also mention one important condition, that is 0 less than a plus b less than equal to 90. That means here sum of these two angle a and b, that is greater than 0 and less than equal to 90. And here another thing is a is greater than b, and we can find angle a and b. So here if I take here first I have tan a plus b is given, that is equal to root 3. Okay. So here you can see that my trigonometric function is tan is given, and here root 3 is given. So here we can write for which value of a root 3 tan is root 3, for which angle. So according to
60 degree.
table you can see that tan 60. Okay, tan 60, that is root 3. Because why I use here tan, because in this one we have tan angle is given, ratio is tan given. Understand? And therefore here I can
Yes, sir.
use tan 60. Now both side tan cancel. Okay, and therefore we can write a plus b is equal to 60. So this one is my first equation. Second, we can get from this one, tan a minus b, that is equal to 1 upon root 3, and here also tan is given, so I can use tan, and for which angle we get 1 upon root 3, that is tan 30. So here also both side tan cancel ratio, that means a minus b is equal to 30, and this one is my second equation. And now if we solve this first and second equation, okay, we can add these two are known as a linear equation in two variable. Okay, a and b are a variable, and it is a linear equation. So if I add these two, so here b cancel, a plus a we get 2a is equal to 90, and therefore we get a is equal to 90 by 2, that is 45 degree. Understand? So here we get angle a. Similarly, if I put this angle a either in first equation or second, any one, so we get a b. Suppose I can use this a is equal to 45 in equation 1, that means 45 plus b is equal to 60. Okay, therefore we get b is equal to how much? 15 degree. And here you can see that second condition is also satisfied. A is greater than b. A is 45, b is 15. And also this condition is also satisfied. A plus b is 60, which is lies between 0 and 90. Understand?
Yes, sir.
Okay. Mm, yes. Next one. Okay. Another example I can take. Similar kind of example. Just 1 second. Yes. Okay. In this question, okay, in a right angle triangle ABC and B is a right angle. So here I can draw the rough figure. Just 1 second. Yes, here I can draw the rough figure and B is a right angle. Okay, and AB is given 5 and angle is given. So here B is a right angle given, so I can take B. This one is A and C. AB is 5 and here angle ACB is given 30 degrees. So this angle is 30. Okay, they already given. And now using this one, we can determine the length of side BC and AC. So here you can, in this question, according to question, we have to assume, or we have to think which trigonometric ratio we have to use. So we find AC and BC. And here this 5 is given. Okay. So if I use this sine 30, sine trigonometric ratio, I can use sine and angle is 30 given. So if I use this sine 30, so that is equal to here, according to this figure, we get AB upon AC. Okay. And now we can use the value of sine 30, that is 1 upon 2. AB is given 5 and AC as it is. Understand? Because
Yes, sir.
that is opposite upon hypotenuse. So here if we find AC, that is equal to 5 multiplied by 2, and therefore here we get AC is equal to 10. Okay. Now we find this value 10. Now BC we can find by two different method. Either I use cos 30, otherwise we can also use cot or tan. Okay, anyone we can use, but final angle this side is same.
Sir,
Suppose
we can
I
even use the Pythagoras.
Yes, otherwise we can use Pythagoras. Suppose here I use cos 30. Okay, for example, we can use cos 30. That is a BC upon AC, because here we already find this AC, and cos 30, that is root 3 by 2, and BC we have to find, and AC that is 10. So here we get BC that is equal to 10 root 3 divided by 2, and that is equal to 5 root 3. Understand?
Yes, sir.
We can also find this BC using another formula, but we get same value. Suppose if here I use 10, okay, 10 C we can use. So that is equal to what? AB upon here, yes, angle C is given 30. So here we can put 10 30. Okay. So according to this one, we have AB upon BC and tan 30 degree. Tan 30, according to this table, tan 30, that is 1 over root 3. Okay, AB that is 5 and BC as it is. So here we get also BC multiply with 1, that is BC, and here we get same answer. Understand? So here we can use a different trigonometric ratio, but we get answer is remain same. Understand?
Yes, sir.
Okay. Okay. Now I take one another similar kind of example, but in this question we have to find angle. Just 1 second. In this one we have to find the side, and other one we have to find angle. Okay, in this one we have a triangle pqr is given. Okay, and right angle at q. Okay, so in this triangle we can consider triangle pqr and right angle at a q is given. So here we can take PQ, this angle is right angle and this one is R, and PQ is given 3, PR is given 6, and then we can determine angle QPR means this angle, and angle PRQ that means this angle R. Okay. Here also we can take third side we can use, otherwise if I use this angle P. Okay, and if I use trigonometric ratio cos P, that is PQ upon PR. Understand? Because that is adjacent upon hypotenuse. So here we have this value is 3 and divide by 6. So we get 1 by 2. So now here we can use cos P is equal to we get 1 by 2. So for which value, which angle for cos theta or cos is 1 by 2, that is cos 60. Understand why I use cos here? I can use cos because here we can use ratio cos. Understand?
Yes, sir.
And therefore we get this p is equal to 60. And now we use angle sum property to find angle r, because this one is 90 degree. So using angle sum property of triangle, that is angle p plus q plus r is equal to 180, and this one is 60 plus 90 plus angle r is equal to 180, and therefore here we get r is equal to 180 minus 150. So therefore we get angle r is equal to 30 degree. Okay, otherwise another method we can use sine r. Okay, if I use sine r for example, that is also pq upon pr, and that is 3 by 6 similar 1 by 2. That means here sine r that is equal to 1 by 2, so sine 30. Understand? And therefore we get also r is equal to 30 degree. So here without finding this third side we can find these two angles. Understand?
Yes, sir.
Okay. Now any doubt in all this topic, trigonometric ratio and this spatial angle, specific angle?
Not so far, sir.
Okay. If you have any doubt, so you can ask me. Okay. Another important thing. Okay. One another very interesting thing about triangle I can explain you. Okay. You when we are most of the things like old buildings. Okay. Pyramid is also, then bridges. Okay, pyramid also is in pyramid. Suppose we have to draw the pyramid. Okay, here I can draw the rough figure of pyramid. Okay, we have two kinds of pyramid. One is a triangular pyramid and another one which is have a square pyramid. Okay, so if we have to join this one, so here inside each side is a triangle. In pyramid, each side is a triangle. You can see that in this figure. Okay, this one first front part, this part. Understand? This one is a triangle. Similarly, this one is a side part. So this one is a triangle, and this one is also in also bridge. In most of the bridge, we you see that this kind of design. Actually, this design is for the strength of the bridge, because triangle is the most strongest structure. This kind of designs we can see in some kinds of bridge. Different design they can use according to the load of the bridge. So that is application. Okay, you can also find into google some interesting things about triangle. Okay, so here you can
All
see
right,
that
sir.
between this one you can see this one is a triangle. Why triangle is the strongest one other than square and rectangle and other? Because if you make either rectangle or a square, okay, and here if I consider triangle, So why triangle is the strongest? I can explain just a second. So here you can see that if we can make a triangle or rectangle, okay, by wooden stick, and here if I uh, here I can take in this rectangle ABCD. Okay, for example, if I apply small amount of pressure at these 2 point A and C, then this rectangle is like this one or this one. It's slightly bent. Understand?
Yes, sir.
And if we consider same wooden stick we can use, and if we apply pressure on this any 2 points of triangle, but it does not change, because if I pressure at point Q and R, for example, so pressure, if I apply pressure on Q, that's go into P and also R, and also if we pressure apply on R, that is also same pressure apply and go into that point P and also this one. So these two are opposite, so pressure is removed, and here same pressure apply at say point P from Q and R, and therefore this triangle is shape of triangle is remain as it is. Because here in triangle, why shape is remain as it is, because this every vertices or point is joined with two vertices, and here also two vertices but not same. Here Q is joined with P and R and means here this, in triangle we can apply some amount of pressure, the shape is not changed, and that is the reason is triangle is the strongest one. And therefore in our old monument, that is a pyramid, Egypt pyramid, that is very old and that is also very strongest, because in pyramid structure, inside structure or sides are form of a triangle. Understand?
Yes, sir.
And this pyramid is origin of this trigonometry. They can use trigonometry to making these kinds of old monuments. Okay, so this one is very real interesting real life application of trigonometry. Okay, now any doubt in this session?
No, sir. No
Okay,
doubts.
okay, okay, have a nice, okay, now my session is complete. Okay, okay, have a nice day.
Thank you, sir. Same to you.
Okay, bye.